In this video, we're going to ask the question and then answer it. How can we assure that an object begins its life in an already valid state? We saw in the previous video that we created the player and its name was null. It seemed that that might be bad, that might be error prone. We might want to ensure that it's initialized to some value earlier than that. So we do that using a special kind of member called a constructor. We've talked before about calling constructors. You create a new expression with an object creation expression. You provide a bunch of arguments that calls a constructor that does something with those arguments. Well, now we're going to see finally how to write those. So a constructor is a method. It's an instance method that's called when an object is being created. When we're writing our own constructors, the thing that distinguishes a constructor is that it has the same name as its containing class. And the only way to call a constructor is via some kind of object creation expression. And we'll see that there are ways in which constructors can call other constructors, but it is always in the context of something kicked off this process, and that the thing that kicked it off was always creating a new object. There's no way to call a constructor without creating a new object somehow. A constructor is often abbreviated CTOR. If you were to take the .NET assembly that is built by Visual Studio apart, you would find that the constructors all have the name CTOR internally. That's just the string that's used to represent them. So I may use that term throughout this series. By accident. If I do, I mean it's a constructor. So why do we have constructors? Well, in our little stub implementation, or the little implementation that we had where we had only properties that didn't do anything and methods that didn't do anything, we call that a stub implementation. You can create a game without a player. You can create a player without a name. It seems like we are setting ourselves up for failure here. It seems like there are cases where you're going to forget that a player might not have a name. It's going to be null. You're going to ask for its length, and you're going to crash. And now we're in Sir Tony Hoare's billion-dollar failure mode here again. So constructors are a way that we solve this problem, right? We say, well, look, a game requires a player. A player requires a name. I am not going to allow a player to be created without it having a name. I'm not going to allow a game to be created without it having a player. If I can do that, then I know that those things aren't null. And if I know that they're not null, I know that I'm not going to crash when I accidentally try to use one of them as though it were not null. So constructors are useful because, one, they allow the caller to provide useful information. And two, they force the caller to provide useful information, right? So that you can know that the object is set up properly before you even begin using it. So let's take a look at some code. Here I'm going to add a constructor to my player class that forces it to have a valid name. Now, I like to put constructors at the top of my class. But you can put your members in a C# class in any order that you choose. It does not matter. The language has been carefully designed so that, except in a small number of cases involving static fields, the order in which things appear in the class does not matter. All right, so here I've got a constructor called player. The constructor always has the same name as the containing class. That's how you know that it's a constructor. Again, we'll talk in a later video about what this public means. Constructors are always void. And because they are always void, you don't say that they're void. You just know that they're void. It's not legal to write void in here, right? C# will tell you, member names cannot be the same name as their enclosing type. Because now it's assuming that you intend this to be a non-constructor method called player. And it's telling you, well, that's not legal. I would get that confused with a constructor. All right, so we have a constructor of the same name as its enclosing type. We have an argument list. We want to make sure that the name is not null. So of course, we do our thing where we throw an argument null exception. You'll notice I'm using the name of operator here. And then I want to assign the property the string that was just passed in. Now, the property that we declared had a name with a capital N. C# is a case-sensitive language. This is name with a small n. So these are different identifiers. Now, it would be legal in here, since the constructor is an instance method, to say this, right? And to say, OK, I wish to modify the name property of this thing, of the thing that was invoked when the new object was created. But once again, you'll notice that Visual Studio does something kind of clever here. It puts this in a slightly lighter font. And it says the name can be simplified because it's not actually necessary here. C# will assume that if you don't say this dot and you name a member when you are inside the class, that you mean to refer to the member. Right? So this is optional. Some people find it much more clear to have that there, and some people find it distracting. I really don't care one way or the other. I'll use either style. But if you have a strong opinion, then more power to you. Stick to it. All right, now let's take a look at our main method. The code that we wrote before is now incorrect. Right? We have an invocation of the new player constructor here, but we've now said you are required to give a name when you create this player. But wait a minute, how did this work before? We had no constructor before, and yet this code worked. It worked just fine. So what's happening there is if you don't have a constructor in your class, then C# will give you a constructor for free. And the constructor that it gives you for free takes no arguments, and it does nothing. If you provide any constructor, then the constructor that you get for free goes away. So that's what's happened here, is we've provided a constructor. The default constructor has vanished, and this attempt to use the default constructor is now an error. If we look at this, it says there is no argument given that corresponds to the required formal parameter name of player.player that takes a string. All right, so we can get rid of this code here that tries to create a new player using the default constructor, and we can also get rid of this code that initializes the name object. Because now we can simply say, well, I want a player. It's going to be a new player, and his name is going to be Eric. All right, so now if we debug into this code, we can then step in to this constructor. And sure enough, we appear in the constructor logic here. This is the player object that is currently being constructed. Name is Eric. The name property is null. We check to see if it is if the parameter is non-null. It's non-null. We change the name. Now the name is set, and we return. And if we look at this player object, then we can see that its name is Eric. All right, so that seemed to have worked out pretty well. Now we also said that we want our hangman game to ensure that it always has a player. So let's do the same thing here. Right? I'm going to create a new constructor called hangman because it has the same name as its enclosing class. It's going to take a player as its argument. It's going to see if the player is equal to null. If it is, then it will throw a new exception. Otherwise, it will assign the property. So very similar to the previous one. And then if we come down here, we see that once again we have the same problem that we had before. We are now calling a constructor that no longer exists. So we will get rid of this code here and say, well, the game is now a new hangman object, and we'll pass in the player. So this is, in one sense, good. We have forced the users of these classes to pass in information that they need. On the other hand, it is bad in the sense that we are now forcing this code to do more work and make more decisions than it did before. It might be nice to have sensible defaults that kind of do the right thing. So let's talk about how we could have a sensible default for the hangman class. Let's go back here. Right. And I'm going to say, you know what? I liked the fact that there was a default constructor that did nothing, a parameterless constructor that did nothing. What I would really like is for the hangman class to give me a new player and use that automatically if I don't specify one. Right? So how am I going to do that? Well, I'm going to create a new hangman class here, or a new hangman constructor here. And I'm going to say, when this constructor is called, before you run the constructor body, run this constructor with a new player. But I have a problem here. This player is missing its name. So, well, that maybe motivates me to do the same thing over here for this player here. So let's say that if I call the player constructor with no argument, that I will call this constructor with the name set to anonymous. All right, so now let's go back to our original code here, right? And let's put a breakpoint here. And just go, and let's see what happens. Let's trace through this control flow. All right, so this says I want a new Hangman game. So let's step into that. We step here and say, OK, you have asked me to construct a new Hangman game using the parameterless constructor. What does the parameterless constructor do? The parameterless constructor now calls the constructor that takes a parameter, and it passes it a new player. OK, well, before we call that constructor, before we call that Hangman constructor, we're going to need to call the player constructor, right? So let's step into that. All right, so what's this guy do? This guy says, well, you just tried to create a player object using the parameterless constructor. What does the parameterless constructor do? It says, I would like you to use this constructor as though the name were anonymous. So let's step into that. All right, now we're here. Name is anonymous. So we do the thing that we should do. We check to see if the name is null. We assign the property. We step back out. And now we're back here. I put these two braces on the same line just to emphasize the fact that there was nothing in them. But if we wanted to have more code in this constructor now, we certainly could. This is a block like any other. We could put a bunch of statements in it, right? Point being that the constructor call happens before the body of the constructor runs. All right, so that block is now finished. Then we step back out. What were we doing? We were about to invoke the constructor of the Hangman object that takes a player object. So let's step into that. Here we go. We have this player object whose name is anonymous. And now we do the thing here. And we set the property to that player. We step back out. We step into this block. Nothing happens there. And we're done. We have initialized our game object here. The player has been initialized to somebody whose name is anonymous. So this is kind of the best of both worlds that we've got here. If you just want something that has defaults chosen for you, then you just call the constructor that takes no parameters. If you want to choose the defaults specifically, then you call the constructor that allows you to specify them. And this is a very standard technique, and we'll see as we go throughout the various episodes in this series that we will add more and more constructors that do more and more things for the convenience of the users. Summing up, constructors are instance methods. They are called only when an object is constructed. You get a default constructor for free, but if you create any constructor other than the default constructor, it vanishes. Constructors can call other constructors before their bodies run, which is very useful. It allows you to share code among constructors very naturally. And finally, constructors can call other constructors using the syntax that we showed, where after the parameter list, you have a colon, and then this, and then the arguments for the constructor that you wish to call.